Checkerspot is operating right now in that thermoset part of the world where the end product that we're making doesn't have that capability set to be reused. What we are doing is enabling what our technology enables is ability to replace a very substantial fraction of what would normally be a fossil-based material with a renewable alternative.
All right, hello everybody. It's a Material World podcast. I'm your co-host David Ye, and I'm joined with me by my friend Puneeth, the other co-host. So Puneeth, how's it going?
Pretty good. I just got back from Yellowstone National Park in Salt Lake City. It was my brother's kind of like graduation trip, and it was really fun. The views were beautiful. The crazy thing about it was we kind of got back before the whole like devastation with the crazy rainfall and everything like that. But yeah, just kind of puts things in perspective, because we were kind of complaining about the rain, but in comparison, we were very fortunate. So that was cool. And then we also got to visit Checkerspot facility in Salt Lake City. Checkerspot's our partner and the focus of today's episode. So it was so cool, not only seeing their skis and how their polyurethane makes an impact, or kind of plays that role into making these sustainably made skis, but we also got like a tease of what's to come. And I think at this point they've released their snowboards, so they're kind of branching out, having new applications, and it's really, really cool. I thought even the design of it was just very well done, so I was very impressed.
Did you get to ride one?
I did not get to ride one, and I would not be good either. So I asked them, like, who's your target consumer, right? And who's your target customer? And Zan was basically like, yeah, it's like professional skiers or like expert level skiers. And I was like, okay, so not me. I remember like back a little while, because I'm in Minnesota, right? So I have to ski, or I had to get on the slopes. That's one of the only things to do in the winter. I was like, oh, maybe I can get a discount of these skis. But they were asking questions about like professional level questions, like, oh, what is this size, or just like your level of skill with skis. And I was like, I don't know. Like, I couldn't get past that. So I don't think it was right for me, but their skis were really cool.
Yeah, I know when you first moved up to Minnesota, I was joking that you can take up like cross-country skiing and just get to work that way. No need for a car, just go back to the roots.
No, I'm so bad. Even with the poles, right? Like just going on flat surfaces, it was an arm workout. I hated it. Like,
you gotta use your hips, I think. Yeah. I don't know. I also don't ski.
You're just like, oh, you gotta use your hips. And I was like, oh yeah, that makes sense. Oh my gosh. So Connor's a buddy of ours. He took me skiing, and I was going down the bunny slopes, right? And I fell a few times, but he was able to like pick me up and be like, all right, do this. Eventually I got down there. I was able to make the turns. I felt good. And he was like, all right, do you want to try a green slope, which is like the next level up, right? And so we go up the ski lift and to what appears to be a green slope, and we go up, and Connor's like, oh, this is a little steep, isn't it? And I was like, I don't know, like, is this the next level? It felt so much steeper than the bunny slope that I couldn't stop myself even on the top. I was still going, to the point where I had to like force myself to fall. Even when I got up, I was at such a slant that I had to like really dig in, and my friends had to hold me. And so I was just, once I finally got my bearings underneath, I was like, all right, what to do next? Connor and our friends go down a little bit just to like scope out the slope and see what's coming and where to go, right? And so I try to follow them, and once I get going, I can't stop. I couldn't stop like right where everybody was. I just zoomed right past them and then kept going. It was just like I couldn't swerve like you're supposed to slow down. I was just going and then constantly accelerating, to the point where I made it. Like, I was going a long way. Like, I didn't fall on the actual slope, but then I wiped out like right at the end. And
Oh,
I was hearing Connor's perspective after the fact, and the slope was so steep that they couldn't see me after I had gone down a certain way until they saw the plume of snow once I fell. It was hilarious. I was thankfully good, but it turns out that was a black diamond slope. It was not a green. So I went from bunny to black diamond. So shout out to Connor. Thanks for that story.
awesome.
But yeah, okay. So that was me going way off tangent. The theme of this episode is Checkerspot's bio-based polyurethane, which can be used in skis, can be used in snowboards, but they created a pollinator kit for anybody to use, like designers, material science students, anybody. And it was really cool just seeing, like, learning about their design process from prototyping to commercialization. Even their packaging was fascinating and required a lot of thought and effort into it. So what was your favorite part of the episode?
Yeah, I think that beyond just the science, which is very interesting, they have done a lot of thought and a lot of effort into how they display it. And so hearing the process of how do we create a package that fosters XYZ was very interesting to hear. And coming from someone with a PhD and 15 years of experience, it's very interesting to hear how her vision and all her experiences are trying to translate to the new generation without shaping what they're doing. And so it's a very interesting blend of, like, I know what I'm doing, but now I want to give you like some tips and tricks to speed up your growth. And so hearing about her journey and like how she wanted to portray the project in the Pollinator Kits was very interesting. What do you think we should look out for?
Yeah, so one thing I really enjoyed doing when I was in Hawaii was surfing. I actually was pretty good at it when I got like a little push. The hard part is actually like the timing, not really like getting up, turns out. But surfing was really cool. And one thing to look out for is how they were able to kind of work with individual designers to kind of crack into a potential surfing application with these materials. So that was one thing that I found super fascinating, very interesting, and something to look out for sure. And the other thing is really just Adrienne's advice for material scientists and why it's so important to kind of branch out from what our traditional path is with coursework and internships to also take on projects and get some creative design experience. It's a new perspective and something new to think about that I think everybody should tune into and look forward to in this episode. So without further ado, let's get into the recording.
Meta Material Inc. is a developer of high-performance functional materials and nanocomposites. Meta delivers previously unachievable performance across a range of applications by inventing, designing, developing, and manufacturing sustainable, highly functional materials. Meta is a fast-growing company with a positive and committed work culture and a phenomenally talented workforce. Our employees are inspired to do exceptional and innovative work and are proud to contribute to the success of the company, and they are our greatest asset. Meta attracts people from all countries and cultures with over 35 spoken languages represented across all our teams. Meta believes that diversity drives creativity and innovation. With locations in Canada, the United States, the UK, and Greece, Meta is growing and is looking for new talented people to join the team. If you're passionate about doing your best work, making a difference, and having fun while doing it, apply to one of our open positions at metamaterial.com/careers.
Hey everyone. We are super excited to welcome today's guest, Dr. Adrienne McKee, Director of Platform Partnerships at Checkerspot Inc. As you may already have heard in previous episodes, Checkerspot harnesses biotechnology to enable the development of high-performance materials, starting with polyurethanes and coatings for a wide variety of applications. They have fully immersed themselves into the MSE community, and Adrienne has played a pivotal role in building relationships that position Checkerspot for future growth and success. Adrienne graduated from Harvard with a PhD in molecular biology, and she has nearly 15 years of experience in the molecular bio space. So thank you so much for joining us today, Adrienne. I'm super excited.
Well, thank you both. First off, I really wanted to say that I really appreciate the opportunity to join your program. We are at Checkerspot are big fans, and I'm really excited to be here. So thank you. And one of the things that I wanted to really communicate as part of our conversation is my enthusiasm and excitement for the momentum that's gaining in the field of renewable materials, including plastics. And so I'm happy to talk about that.
Sure. Awesome. So yeah, you're leading us straight into what we want to talk about today. So Adrienne, when we talk about sustainability in plastics, we've heard a lot about it. We've heard about the straws and single-use plastics become a huge issue with companies trying to become biodegradable and things to make it more sustainable. But there's a lot of things out there. And as an MSE, what should we think of, or what is the main focus in making new ways of making plastic to be more sustainable?
Great. That's a really, really good place to start. And I think it really sets kind of an overarching, I'd say, umbrella for where Checkerspot fits in, and then all of the other things that are going on in the space. And I think people are hearing about it and people are seeing a lot about it now, but there's been a number of converging reasons why this is the case. As I've been in the industry for almost 15 years, seen where it started to where it is now and to where it's going, it's really exciting. Just to highlight on a couple of the converging reasons, I think that we're seeing a lot of corporate and government accountability, particularly in Europe, along with rising consumer awareness and demand for what their products are made of and how they're made. And then as a technologist originally, we're seeing advances in the technology. And I would put those in kind of a couple of different cases. Some of those are in how we're accessing carbon. So we've been accessing carbon by drilling it out of the ground for over 100 years now. We're finding ways to access carbon in other ways, whether that is biogenic or atmospheric. And so the processes that are allowing us to do that and to think about the end of life use cases, those are also evolving. And so we're seeing technology advances there. And as a sort of a gross simplification, I like to bucket sort of like the renewable materials outputs into three different camps. I think it's a framework to consider. One of those is like the direct swap in and swap outs for fossil-based monomers. Another one are molecules that are new, but they are made in different ways and largely work within the systems and existing processes that we have and sort of come to know. And then lastly, there's a third bucket of materials that I think is really exciting, that don't have a good correlation to a lot of the legacy materials that are out there. And so as MSEs go throughout their training, I think it's very important that they learn about these different types, all these three different buckets, because they each have different benefits and trade-offs for what's possible both now and in the future. I think that MSEs will be faced in both in their coursework and as they enter the workforce, they'll be presented with choices that come at the intersection of materials and processes. And those choices have big implications for the kinds of bigger solves that are important. So it may be a particular use case, it may be a certain specific question, but that does feed into a bigger system. Making plastics from fermentation, which is largely what we do, or from flue emissions, for instance, can be done in a carbon neutral way. It can also, but more importantly, it can reduce pesticide use, it can reduce land use, it can reduce water use. And all of those things together can turn out to be really significant beyond a number or a score that's sort of reported in an LCA. So kind of in a roundabout way, many of these materials, including these new kinds of plastics, they'll have different capabilities of different limitations, but it's critical for the problem solvers of the world and the growing problem solvers of the world to understand what those properties enable and what those macro trends can be that are resultant or emergent from their use.
Yeah, for sure. I just had a quick follow-up then, or I'm not sure really how quick it is, because really I guess the challenges we face as MSEs is, how do you understand that full scope? You mentioned like water use, right? Carbon use. How do you understand that full scope when you're making these materials development, materials design decisions?
Great question. And I think that goes hand in hand with working with groups that do life cycle assessment and other types of product evaluation. And every company in the space who is making a new material that has gotten to any kind of critical mass will have, it is industry standard to conduct these. It's not just about the scope doesn't just begin at the product. It goes back all the way to how the raw materials for what goes into that is also impacted and selected. I think that there is a growing use case to make a lot of this information more manageable. One of the things and challenges that I run into, and I can't imagine I'm alone in this, is that it feels like all of the metrics and the denominators are in different units. And so just figuring out how to translate units into something that's relevant to the project that I'm working on, it can be quite a headache. I think that there are a lot of smart people out there, and as we start putting our heads together, we'll develop systems that work a little bit better. It's not any really different than what happened when probably people were manufacturing pipes for the first time, and people had to get together and decide that there was going to be a dimension of how pipes fit so that you could work in different places of the world. I think that that's coming, and I think it's really important.
So as someone with 15 years of experience, you mentioned that we have varying buckets and they have varying degrees of benefits and trade-offs. And so we're going to have things that are like much more sustainable, both on the beginning of life and end of life. And then some things will have beginning of life, etc. As someone with so much experience, what's your philosophy on the transition? So we start with something that's not very sustainable, and in the end, we would love to be 100% sustainable. How do we, as a civilization or a society, transition with those buckets that you talk about?
Wow, that is a phenomenal question, and I would say that I'm still developing the answer for myself, honestly. But it is something that is top of mind all of the time, and becoming more so as I select the projects that I feel really fortunate in that case, but also the kinds of companies that I will ever work with in terms of my ethos. I like to say that even Shakespeare got to get paid. And so I think part of what it will take is not just the conviction that this is an important thing to do, but having the carrots be in the right place for lots of people to make this the easier choice. I think there's a lot of people who would prefer to have not just their phone cases made out of renewable materials, but the insulation in the walls of their house and the carpet that they step on and all of those things. And we can do that. I think what it comes to is getting some of the bigger levers beyond demand signaling, which is absolutely important. Consumers need to make decisions with their pocketbook and with what they buy and they don't buy. That absolutely feeds back. But there's additional levers. And I point to Europe in that the countries there have been able to more widely adopt, I think, are bigger policy enactments that allow these sort of more renewable materials to take place. It takes much more than just the idea of how to make something new. The world has to be set up in a way to embrace it and push it forward. And so policy is really important, and engaging with people who have the capacity to set those policies is also a big step.
Cool. And so that kind of leads us to the theme of this episode. So Checkerspot is providing designers with a material that is 57% bio-based, and materials like designers interface a lot with polyurethanes, and that's kind of the focus of this project. But maybe you can elaborate on what exactly the material is, how the process works, and your vision for what MSEs can achieve with this technology.
Great, absolutely. So let me just step back a tiny little bit to explain what kind of the class of polyurethanes are and how they differ a bit from sort of what people, I think, traditionally consider plastics. So these are by and large thermosets, which means that they won't remelt back into their original monomers when you heat them up. So think about the foam in your car seat, in the couch, the insulation in your walls, the casters and rollers that are part of machines that allow us to do the things we do, and even the coatings on circuit boards. Those are often polyurethanes, and it's a very, very broad type of material. The smaller subset of polyurethanes are thermoplastics, which do have that potential to be remelted and reused. But in contrast, that's just a much smaller focus of the market. Checkerspot is operating right now in that thermoset part of the world where the end product that we're making doesn't have that capability set to be reused. What we are doing is enabling what our technology enables is ability to replace a very substantial fraction of what would normally be a fossil-based material with a renewable alternative. We're definitely not the first to develop bio-based polyurethanes. There's been a number of companies for decades that have used other types of inputs, but our process is different, and our our raw material renewables are different as a result of that process. So we biomanufacture the starting point of what goes into our urethanes. And our process uses a type of microalgae that are really, really good at converting sugar to oil. Just in the way that yeast can convert sugar into different types of ethanol that people know about in different ways, these microbes have pathways that consume sugar, and instead of ethanol, they output triglyceride oils. So think of olive oil, that's a form of triglyceride oil. But coconut oil is also a form of a triglyceride oil. And the specific structures of those oils have implications on their functionality and then the resulting materials that you can make from them. We have the ability to program what kind of oils the microalgae are making. And so as a result give some advantage starting points to the materials that can be derived out of those different oils. In all of this, my background and sort of, towards your audience asking how is a molecular biologist related to any of this? So I started off as a molecular biologist and got into the genetic engineering of microbes to make things. And so hence how I'm here. But from an oil, we make a polyol, and then we formulate it with other chemicals to generate different types of polyurethanes. And actually, some of our formulations are now just north of 70% bio content. So that's some of the background work to just sort of set the stage to tell you about a project that I've been working on that's really transitioning now from the prototyping stage into commercialization. I'm really, really, really psyched about this because we're introducing our formulations in a way that we hope that makes it really easy for people to use them. One of our missions is that of empowerment. We want to get new materials into the hands of designers and honestly, anybody that's hungry for change. Particularly something that we're cognizant of is that new materials companies often focus on commercializing through a limited funnel, and that often through very large some other large company, a well-known brand, or somebody that already has a direct to market channel. And that is really valuable. And we also want to support that methodology, but not at the extent of excluding others who also want to participate. So my team sees this on a daily basis as we get inbounds from creators of all walks of life, from big brands to small design firms to people in their garages, saying that they would like to participate in some capacity. And the project that we put together now enables a wider audience to be able to come and participate. So what we did, and it sounds pretty rudimentary, but it's actually been quite foundational or transformational, is that we created a kit. We actually built a kit, like the kind of thing that you might see in classrooms in sort of grade school, but really geared specifically towards ease of use, towards reducing the amount of other types of packaging that's currently used in the industry, and focusing on of making it exciting and fun and interesting to work with. So it's a casting kit. I'll show you. So it's about basically the size of a shoebox. It would come normally with some tape on it around this where it opens like a book. And in it, there is an A side and a B side. There are other casting kits like this on the market, but to our knowledge, this is the only one that has any kind of bio content in it. We're also providing, so we make materials that go into both of these sides. When you add them together and you mix according to the right ratios, you get a product of whatever shape it is that you are dictating or coding or whatever you'd like. That is 57% bio-based. We're also providing it is here, a stir stick that functions as, uses to mix, but it also operates as a form factor for what our material is like. And so people get a sense of the look and feel and the capability set of what this material can do. So you can tell it's a little bit bendy, but it snaps back. So we're hoping that folks use that as a stir stick, and then providing a reusable silicone cup in addition. The bags themselves is a different and new way of serving the market. Urethanes in this kind of smaller quantity typically come in containers, a plastic HDPE or some sort of thicker plastic. We've been able to package these in such a way that reduces the packaging level the plastics level by 5x. And if anyone gets the opportunity to work with designers at any point, they should definitely jump in with both feet, in that the thought process has led to creating the design of the kit in such a way that as it folds out, you can use the box itself as a secondary containment. And we've also decided to take the instruction manual and make it to be a fold out, kind of like as you're maybe putting together Legos, you would unfold different parts of the thing.
Yeah.
And it's, in a mat fold that you can use to set out
wow.
on the surface of your workbench. So effectively what we're doing is providing everything that somebody would need to work with this material to obtain a form factor that they are interested in driving towards. Often people cast with this kind of material, so you would need some sort of molding surface to cast into. We are not providing that in the kit. That's going to be driven by the choice of the individual. But there are lots of those kinds of examples online, and we'll be presenting links to those kinds of resources.
That's awesome. I'm just curious, what was that process like going from like this prototyping stage to the commercialization? I know like David and I got these like little glimpses throughout the process, and it was always so fascinating, but it seemed like even with the packaging, like that was a whole process in and of itself to design and like perfect even the instruction manual too, right?
Everything about this particular project has been a really curated and thoughtful endeavor. I feel really fortunate to have the time and the support of Checkerspot for us to be able to spend this amount of focus on something like this. Definitely moving from prototyping stage to manufacturing is a whole nother set of skills. And I think actually many people will encounter this in their fields as they move up. There's a lot of coordination and there's a lot of vendor management. And being able to do those well can be just as valuable to the overall success of a project than as the design and the folks that are doing the formulation. I think that's a part, like the logistics and operations of how actual products are made and assembled and inventoried and cataloged. Is every company needs to do it, and there are absolutely people who do that very well, and I'm very fortunate to have a number of those people here. We just finished a process of having a number of these kits that were sort of, I'd say, artisanally made, so not in the manufacturing process, but we sampled them out to, I'd say, 24 different folks across many different walks of life, and got feedback. And that's also towards your question of what's important. Iteration is really important. And also many of the assumptions that we made along the way about what would be valuable versus less valuable, we're getting true feedback from people in the field using the materials and engaging with them. And that is always really, it carries its weight in gold in terms of making decisions. I'd say the ability to actually prototype in the wild is really important.
I am really amazed by the packaging, especially because Puneeth and I have done projects for school and in my own research. It seems like you have to get 7 different vendors for all these different little parts. And so it really breaks it down to now you have everything you need to succeed. Now you just need to actually implement it. And so that kind of leads us to our next question is, for us, usually it came around school where we have a project we want to make, but you're going beyond that. You're trying to inspire the next innovators, one of your big mottos. And so now that you have this kit, and personally, I think that my favorite part of like inspiring me is that it's so easy. Now there's nothing holding me back. What was that process like to create the atmosphere of creativity, to create the next thing, to break it down?
Really, we benefited by working with designers who asked the questions that we weren't asking. I think there's at a very high level, when we set out to make a kit, we could have just made a kit. We could have taken things that already work together very well and just put some labels on it, and then we would have been done. The group of people that's been working with on this project asked at the very, very beginning, well, who's going to be using it? And we couldn't even directly answer that question because we basically could come up with 10 different types of people that we hoped would be using it. And so there were a lot of conversations before we even got into the sketching stage of why are they using it and where will they be using it and how will they be using it. And so that really drove what the look and feel could be. From there, we went through a number of iterations to finally settle on where we're at today. And I think that question of who and why, I guess it's 2 questions, really was helpful. And it wasn't taught when it really became a driving and forcing function for us to get resolution about the project itself. We're a small company, and we really value other people's ideas for many reasons. We get better because of it, but also we can't do everything. And so we're just limited by the number of hands and hours there are in a day. There's a brilliance in sort of opening the garden walls up to people who already are raising their hands and looking for things. But basically what we're hoping to do with this project is just reduce those barriers to find those folks who are interested and enable them with materials that do actually have, that move the needle in terms of carbon, and climate change.
With all of that being said, you kind of touched on it, but what are you hoping to accomplish with Checkerspot's like Pollinator Kit, and what is like your vision for this? What is maybe like that best case scenario?
I think it breaks down into a few different areas. Top of mind, and this plays back into how we're a small company and we want to really address the long tail of people who are interested. I'm hoping that this is an avenue for that to happen, that anybody who wants access to this can go to our website and buy it. We're also going to be working with schools, different types of university programs, and different colleges to make this available. So effectively, and the reason it's called the Pollinator Kit is in that we hope that it seeds activity and awareness of renewable materials, not just ours, but the field in general, and to make something engaging and easy to use. That's the top of the list. And sort of in addition to that, we hope to find those designers who really are setting the look and feel of a project and get them familiar with our materials so that either they have an existing project now or they will know of it in the future when they make a choice later on down the line. That sort of network effect gets going in a way that we wouldn't be able to as a fairly young and sort of nimble company in the field. And then I guess lastly, what's really, really fun in working with designers, but really kind of creatives of any walk of life, is that we have some ideas about things that we would make, but we're always blown away by the new things that come out that we would not just never we wouldn't have done that, but we wouldn't even have thought of it. And those are the really, really fun things. I mean, they're all really fun, but when you're completely, blindsided by something that you didn't know that you could put A and B together or even think about it. And we've just in running the beta program for this kit, have seen that on a few occasions, and that's really cool.
And so I think a really unique part of this program is that, like you said, you're going straight to the innovators. And so normally innovation goes through big companies that then trickle down to consumers. So one big aspect of this is with any R&D, usually companies think in millions of dollars for new tooling. So a very important aspect is, how do you process it? Could you walk through Checkerspot approach to make sure that by going straight to the consumers, you still make it accessible for them to process?
Great. Yeah, great question. And that plays back into my 3 buckets of different types of materials. So in this case, the cast urethane formulation, then the one that we selected to work in this kit, is amenable to hand mixing. Actually, people can just shake the bags and get a pretty sufficient mix to basically stir up all of the contents, particularly that's in one of those pouches. That's important in order to combine them and harden together. The mixing is a field that is art and mastery, and there are in lots of different ways of processing materials. The right kind of mixing is really about the equipment and the attention to detail. It's no different than making whipped cream. You've got to have the right tools and sort of wait for that that conversion point to happen. What we expected to be true is that in this small of a volume, these aren't drums and these aren't vats of material. There's a kind of a limitation to the types of tools that people will have available to them to mix in those small volumes. So the formulation has to be robust enough to work with sort of what we would call sort of just garden variety mixing. And that was part of the reason that why we went with bags, because you can really get a very good mix. And then also you want to be able to see what a visualization is really valuable for a lot of folks. And with the clear packaging on one of the sides, you can see whether things have achieved that. For people to use this kit, they don't need any special new equipment. Anything that they're using today, it will be amenable with. There are, as I mentioned, there are kits out there on the market that this is a very good, I'd say, substitution for, and probably things that folks already have kind of top of mind. In sort of more of an industrial setting, having the capacity to work with the same kind, so mixers will be actually very detailed and pumps will be very elaborate, and the kinds of fitting into that kind of process is also really important for fast tracking the use of the materials. But I think so that comes to a real benefit for us to be able to drop in as kind of a widely overused term, but to be compatible with sort of the tooling and equipment that is known in the trade. But I think, there's a phrase that if you're going to make your own software, you're going to also have to make your own hardware. And for new different kinds of materials, for us to really leverage their benefits to society and to the kind of other properties that they bring, will also have to generate the new equipment that is necessary for their implementation.
That's awesome. So one thing that I feel like we generally miss out in school, at least with coursework, is this creative freedom that you're talking about, to essentially take a material and then you have total freedom to just see what happens and potentially like create applications outside of that. So we don't really get that in coursework and even in quite a few internships. So I was just wondering, why do you believe it's so important for us material scientists and engineers to gain that creative design experience in addition to kind of what we gain in the classroom?
I have STEM training, not in materials science and engineering, but in different form of science. And I think there's a mentality that kind of gets ingrained in the training to really go after the specific question that's being asked. What I have had the benefit of seeing in the year or so working on this project with a whole number of designers is the ability to ask beyond the question that's being asked to the why and the who, but then also the question that hasn't been asked, whether or not it was a good idea or not to do it in the first place. So there's also a mentality that designers challenge each other with critiques on nearly a daily basis. This was something that was really foreign to me. Feedback in my own training came either really in an ad hoc way or in super formal, very high stakes meetings with advisors and committees. And in either case, it was not impactful enough because it was ad hoc, or it was so momentous that it felt scary to have any kind of criticism. And so this method of review and discussion and constant ideation is something that I think is impactful for MSEs if they're not getting it in their STEM training, to seek it out in ways that is valuable, because getting those sort of like kernels of, or I'd say like bite-sized inputs is really helpful in changing ideas kind of in a more gradual way. But then zooming out, like there's just the breadth of experience and perspective that comes from working with people outside of your field is important, because as any idea gets goes from ideation to execution to commercialization, goes through lots and lots and lots of people. Getting their input ahead of time, or knowing what their influence is and being able to understand how they make decisions, is really key to being successful in the workplace and by and large. And then I guess I would say lastly, don't stop at designers. Take the finance team out to lunch, take the communications director, your work, because they're the ones who are going to be talking about it. And so getting other people's perspective early and often, I think is some takeaways that I've definitely come to appreciate from working on this project.
You mentioned before that this material excites you because you now have this direct contact to the people who will actually be using it and innovating with it, which has sparked innovation otherwise might not have been possible. Could you elaborate what it's like for a large materials company, or just a company at all, to interface with like these small consumers who are going to be trying to innovate with this material? And then what example of any innovation that has been sparked by this direct contact?
Yeah, sure, absolutely. So one of the things we did in the course of bringing this out in our beta is work with some of those inbounds of, I'd say, very small small companies and also individuals that have been reaching out to us throughout the course of my tenure here at Checkerspot. An example is with a gentleman named Jeff Lenore. Jeff Lenore is the founder of a nonprofit called Waves Not Plastic. And through that channel, he develops and distributes educational materials about the health of oceans. He's also a giant surfing aficionado and knows everything about the industry, everything about the materials, everything about the who is using what and where and how. And we asked Jeff we didn't ask, he was, I'd say, early adopter number one for the Pollinator Kit, and took it upon himself to create a surf fin set. And he's actually been traveling around the world riding on some of the fins that he's made from this kit. And so beyond the design, I think what was really momentous for us is that he's really pushed us to consider the market fit, and hearing the strength of his arguments and the conviction that he's bringing to them is just as exciting for us to see as the design and the parts that are coming out of it. And so it's not quite a direct answer to your question, but it was a wonderful, unexpected thing that has happened to us. And I'd say that is emblematic of a few other instances that's happened, and we were not yet even commercial with this. One of the things that his engagement has done is challenge us to improve the material quality for the specific type of application. We already knew that work would need to happen if we were going to enter into making a surf fin, for instance, but it has gotten us into answering that question faster than we both thought we had ability to do, and in ways that we didn't think about when we sort of said, yeah, we're going to need to make this material more stiff. And so I'd say his enthusiasm has led to changes on our side that have been really, really great, and don't just allow us to make surf fins, but to improve our materials overall.
That's so cool. I remember, like, this was in episode 11 when we first learned about Checkerspot, like a year and a half ago. I had searched up like, what can polyurethanes be used for? And one of the first things that came up was like surfboards. And I was like, that's so cool. And I think I even asked about it way back when. So now it kind of just to see that come to fruition a little bit with the surf fins, and just how that stemmed from this direct to designer collaboration is awesome. So with all that being said, I just want to hear what's next for Checkerspot materials.
A couple of things that are really on the water, so to speak, is, we're really working hard on foams We've already been using them today. So again, this is a different type of polyurethane, but polyurethane nonetheless. We're using them today in the build of our skis. But then there's additional areas and property sets that we're looking to basically solve, because we have a lot of interest in that area. And the volume of foam in the world is a much more vast. And so having that capability set to really make high quality foam with the bio-based contents that we're able to achieve is something that we're really excited about. And then I think you also mentioned we are working on textile coatings. And that's an area that's a really fossil fuel heavy application set that is really invisible to a lot of people. You don't really think about it until it doesn't work. Sort of your jacket becomes water permeable, or you scratch something on your car, and then you have something else that happens to it. And so despite they're basically being invisible in the world, they are almost everywhere. And so be on the lookout for some news for us there in terms of how we're going to be coming to market with some textile coatings, because that's going to be it is really exciting. And then basically on the kit, as we mentioned, we're launching a website in the next few weeks under the URL pollinatorkits.com. And folks can learn more about what the material is, see what some of the other products that we have been making, what other folks have been making from the same formulation, and buy a kit as well.
And so for this project, you talked about these great new applications. Do you envision growing upon the base pollinator kit into these new applications, or how does the evolution of this kit look like?
Great question. I think it kind of channels into different areas. As is, the material, the formulation that we picked that's going into the stick is really useful for a wide variety of end-use applications. In the world of polyurethanes, there is no one urethane, and the sky's the limit in terms of the number of formulations and properties that can be achieved. And so we anticipate that there will be a use case for just the formulation that we have, and that will be, ideally growing over time. But the capability to then work with people directly to solve the property sets that they are really looking to achieve is one that we are baking into the foundation of our company. And so we have formulation teams that will be able to engage with people to say, okay, I'd like to make it, but I have another stick. So, beyond this guy, we need something that's really bendy. For instance, and we need it to cure under these conditions. And so having I'd say all under one roof, going from molecule to formulation, is something that in the biospace hasn't really come to fruition. And we're excited and challenged to be right at the bleeding edge of that sort of change.
The bleeding edge, I like that. So you mentioned in a previous call, just like the potential applications and kind of what has come to fruition in the beta stages. I remember you mentioning footwear, visual displays, and art. I was just wondering if you had any favorite applications or something that like caught your attention, something that comes to mind right now.
Oh, that's a great question. I think the existing formulation, we can put it into a lot of things that looks like prototypes. So I'm sitting here with a skate wheel, looks like prototype.
Oh, cool.
Yeah, it's not a works like prototype.
Big difference.
And so back towards the question of what are those two other avenues? This will definitely go into okay, now we need to formulate to make this a little bit different. What really excites me is those use cases that we solve more than just can you make a blah. It's like, why are you doing it, and does the doing of it solve some sort of broken system that we didn't really need to have in the first place? And so I wouldn't say that I've had like this is the one thing, but there's definitely a modality to that thing. And so can it save energy in the manufacturing of it? Can it save, whole other parts of the building materials that you no longer have to use? Those are the things that are my favorites and that are the exciting things to me beyond it can work and it can create really cool things.
Yeah, I just still love the idea of someone just replying back to you guys on email and saying, oh, I need this tougher, and then you just send them out a new kit. So I think that's a really cool interaction that could happen. I guess wrapping up today, what would be one final piece of advice you would give to material scientists and engineers who want to help us transition away from petroleum-based polymers, and then also who want to use this kit to innovate and try something new and gain design experience?
Yeah, great. I'd say work on a project, like for the first question, seek out those projects where these materials are being used in whatever shape or form they are. It's going to take a lot for us to sort of get to a post-petroleum future. And there's a quote by Isaac Asimov that I used to have at my bench in grad school. And I still think about it a lot, that there's a single light, shining light of science, and to brighten it anywhere is to brighten it everywhere. And so that sounds a little trite, but I do think it's important, particularly those materials that are not drop-ins, I think can have some of the biggest impacts. And getting more people to use and engage with them is really, really important. Even if it doesn't end up being the thing that that person ends up doing for a living, that's okay. Just the knowing about it and being able to share that knowledge in other ways was really what's valuable. And then I'd say specifically to our materials, reach out. We're always working with folks. We're based in 2 locations. We're in the Bay Area and we're also in Salt Lake. And we have a tiny but growing footprint on the East Coast. So we have so much to do, both as companies and individuals, that there's always something. And regardless of how it fits, it definitely, there's a lot to do.
For sure. Well, thank you so much, Adrienne, for joining us today. This was really cool. And I'm so excited to see these pollinator kits take off and for the network effects that you mentioned to come into play.
Thank you, guys. Yeah, we're really excited as well. And thank you again for the opportunity to be on your program.
Yeah.
As a materials engineer, we can make an impact in nearly every single industry. But with that versatility comes a lot of different options to choose from. So if you have no idea which industry or position is right for you, believe me, you're not alone. I've been there, done that. But just for a moment, imagine narrowing down your ideal role and company by the end of this week. Imagine being able to secure your dream job offer without having to apply to hundreds of job openings. Our online course, MSE Academy, includes video testimonials, resumes, interview prep, and mentorship from materials engineers who have been in your shoes. We also connect our members with companies and industry professionals in our expansive network to help accelerate your job search as much as possible. To learn more and get started, simply click the link in the description below. And if you enroll within the next 24 hours, we'll add 3 bonus career development resources. I hope to see you there.